Hi boys and girls, this is Miss Christie, and tonight's lesson is on probability. So we worked on this a little bit today, and this is the homework that I gave you. So I just want to go over it because I think that some people are a little confused still. So this first part here explains how to find the probability of simple events. When tossing a coin, there are two possible outcomes. And remember, outcomes means what the result is. So you toss the coin, you could get heads, you could get tails. Those are the outcomes. The outcome is if it's heads, that's an outcome. If it's tails, that's an outcome. Suppose you're looking for heads. If the coin lands on heads, this would be a favorable outcome. The chance that some event will happen, in this case getting heads, is called probability. You can use a ratio to find probability. The probability of an event is a number from 0 to 1, including 0 and 1. The closer a probability is to 1, the more likely it is to happen. So if you look here on this chart, 0, which also means 0%, means it can't happen. 1, which is equal to 100%, it means it's absolutely going to happen. And then 1/2, or 50 hundredths, or 50%, means that it's equally likely to occur. So that's like our heads and tails thing with the coin. And then 1/4, which is equal to 25 hundredths in decimal, or 25%. And then 3/4, which is 75 hundredths, or 75%. So these also show you a fraction, an equivalent decimal, and an equivalent percent. Okay, so here's the first example. There are 4 equally likely outcomes on the spinner. Find the probability of spinning green or blue. So remember, we talked about how the ratio is a fraction, the numerator is the number of favorable outcomes possible, and the denominator is the total number of outcomes. So in this case, there are 1, 2, 3, 4 possible outcomes. So it could land on red, blue, yellow, or green. So it's 4 possible outcomes. So there's the denominator, 4. And then what's the probability of getting green or blue? So green or blue, 1, 2. Those are 2 of the 4 possible outcomes. So that's why the fraction is 2/4. And then remember, we talked about how you need to simplify it. So simplifying 2/4, they're both divisible by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So it's 1/2. So the probability of landing on green or blue is 1/2, or 50 hundredths, or 50%. And then this is just a little blurb about complementary events, which are 2 events in which either one or the other must happen, but both cannot happen at the same time. The sum of the probabilities of complementary events is 1. So that's like the heads or tails thing that we talked about earlier. Okay, so here's our example 2. There is a 25% chance that Sam will win a prize. What is the probability that Sam will not win a prize? So it's not asking you what's the probability that he will win, it's he will not. So first we have to figure out what that percent is. So if there's a 25% chance that Sam will win a prize, then we have to subtract that from 100, and that gives us 75, or 75%. So there's a 75% that Sam won't win a prize. As a decimal, 75 hundredths. and then as a fraction 3/4 because 75 hundredths, well, what's the greatest common factor of 75 and 100? If you just think about it like money, 3/4 are 75 cents, 4/4 are $1. So 25 is the greatest common factor of 75 and 100. So you're going to divide both by 25, and that's going to give you the 3/4. And that's what the answer is. Okay, so now the actual problems that I wanted you to do for practice. So number 1, there's a 90% chance that it will rain. What is the probability that it will not rain? Again, that it will not rain. So if there's a 90% chance that it'll rain, and 100% is the total, you can't have any more than that. So 100% minus 90% equals 10%. So the probability that it will not rain is 10%. 10, I'm going to write this over here just to make more room. So 10%, and if we were to make that a decimal, remember 10% equals 10 over 100, or 10 hundredths, which is written as decimal point 10 hundredths. And really this 0 is irrelevant, so you can have it, but you don't have to. And then as far as the fraction goes, 10 hundredths, well, we're going to make that 1/10. So if it asked you to write it in a percent, a decimal, and a fraction, that's what you'd write. Okay? Okay, so now with these 2, 3, and 4, 1 pen is chosen without looking from a bag that has 3 blue pens, 6 red pens, and 3 green pens. Find the probability of each event. Write each answer as a fraction, a decimal, and a percent. Okay, so let's start with number 2, the green. So how many green pens are there? There's 3. There's 3 green pens. All right, again, I'm going to write this over here just because I have more room. So there's 3 green pens. How many pens are there all together? So there's 3 blue, 6 red, and 3 green. So there are 3 and 3 is 6, and 6 is 12, so there's 12 pens all together. 12 pens total. So using our fraction here, the number of favorable outcomes over the number of total outcomes, 3 favorable outcomes are possible, and there's 12 total outcomes possible. So our fraction is going to be 3/12. But what do you notice about 3 and 12? Do 3 and 12 have a common factor? Well, 3 is a prime number, so 3 doesn't have any factors except for 1 and 3. So the only question we really have to ask ourselves is, does 3 go into 12? And it does. So we can divide this fraction by a factor of 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So our fraction in simplest terms is 1/4. There is a 1 out of 4 chance that a green pen will be chosen. So we've written our fraction. Now we need to write our decimal. 1/4. So if we look up here, we can see that 1/4 is equal to 25 hundredths and 25%. So 25 hundredths and 25%. Now if that wasn't written up there, we could figure it out by making 1/4 equal to how many hundredths? Well, we know that 4 times 25 is 100, and 1 times 25 is 25. So that would tell us it's 25 hundredths, and we know that to write 25 hundredths as a decimal, that's what it looks like. Then we also know in order to turn it into a percent, we multiply it by 100, because percent is out of 100, move the decimal over 2 places, and that's 25%. Now, what about this one here is asking what is the probability of us getting a blue or a red pen? Blue or red. So, if we look here back at our problem, there's 3 blue pens and there's 6 red pens. So to get a blue or a red, we have to add together 6 plus 3. 6 plus 3 is 9. So 9 is our number of favorable outcomes. And again, our total outcomes is still 12. That doesn't change because there's still 12 pens. So there's our fraction, 9/12. Can we simplify 9/12? Do 9 and 12 have any common factors? And if they do, what is the greatest common factor? Well, we can factor out 9 pretty easily. So 9 is either 1 times 9 or 3 times 3. 12 is 1 times 12, 2 times 6, and 3 times 4. Oh, look! Here's a common factor right there. And 9 doesn't go into 12, so that's the greatest common factor. So we're going to divide by a factor of 3. 9 divided by 3 is 3. 12 divided by 3 is 4. So our simplified fraction is 3/4. So we're going to put that here as our answer, 3/4. Now we also need to put a percent and a decimal. So again, we just look up here and we can see that 3/4 is 75 hundredths. And that is equal to 75%. And then our last choice is not red. What is the probability that we get a not red pen? Well, there's 6 red pens and there's 12 pens altogether. So how many are not red? 6. So 6 is going to be our numerator for our fraction. Our denominator is still 12. So 6/12, right away you should look at that and immediately notice that 6 is half of 12. Therefore, 6/12 is equivalent to 1/2. Anytime the numerator is half of the denominator, the fraction is equivalent to 1/2. So there is a 1 out of 2 chance that you will get a not red pen. And then we know that half is written as 50 hundredths or 5/10 as a decimal, and it is 50%. And that is it. And that's how you do those problems. So hopefully that makes it a little more clear, and I will see you, some of you, tomorrow. Bye-bye.